When we think about weather and we think about climate, we have to talk about water in the atmosphere because that's one of the primary things that's going to alter what our climate is like and what our daily weather is like, is how much water is available in the atmosphere, and then we talk about temperature as well. So one of the biggest things about water that impacts climate and weather is the fact that it can change its state of matter. So when we talk about going from a solid to a liquid to a gas, you think about it, if it couldn't do that, if it couldn't change from a solid to a liquid, or if it couldn't particularly go from a liquid to a gas, we wouldn't have clouds. And so the water cycle is completely dependent upon the fact that water can change its state of matter. So it can go from the liquid that's in the lakes or the oceans, it can evaporate, right? It can be heated up, and it can go from a liquid to a gas, and then it can cool down again and can go back to a liquid where we get our precipitation from. So when we look at what's going on with our weather, it's really important to remember that water can change its state of matter. Now, as far as weather is concerned, where the solid part, the ice part comes in, is where it's cooling the atmosphere. And so in our northern reaches, in our southern reaches, down near our poles, where we have lots of frozen water, that's where we have a lot of cooling that occurs. And we'll talk about what happens with cooling air and what's the impact globally when we have air that's cooled down a lot here. But our normal cooling doesn't happen necessarily because there's ice there. Our normal cooling that relates to weather happens because we've increased in elevation. We've gone further off of the surface of the earth, and the air expands, and so the molecules aren't as close together, and so it loses heat. So when we talk about that weather in the air, we're talking about humidity. So humidity is just a general term, and on your handout, you have places to fill in the words that go along with all these different definitions, and then we'll talk about how they kind of all go together. So we talk about that vapor that's in the air. So the water, the liquid water that was in the lakes and the oceans has heated up and has become a gas, and we refer to that as humidity. So when it's reached its complete full point, that's what saturation is. And I want you to think of like a sponge that you've been pouring water into, and when you get it to where it's saturated, that sponge can't hold any more water and it just drips out. And that's what the saturation point of air is. It's basically that the air has held all the water that it can, and once it's reached its saturation point, now it's ready for precipitation to occur because it can't hold anymore, just like the sponge couldn't. Where the water drips out of the sponge, the water's going to come out of the air. So one of the important concepts is what's right down here at the bottom of the screen, and that is that warm air can hold more moisture than cold air can. So the saturation point of warm air is higher, which means that the humidity has to be higher in order for it to rain. So in the wintertime when it's colder, it doesn't take as much moisture for rain to happen because I'm going to go back to my sponge analogy. In the summertime, the sponge is really big. It takes a lot of water in order to fill up the sponge in the summertime because warm air can hold more moisture, a bigger sponge than cold air can. In the wintertime, the sponge is really small, so it doesn't take as much water in order for it to reach saturation and for it to rain. So the one that you hear about on the news, and when they talk about, oh, the humidity today is, they're talking about relative humidity. And that's why it's always in a percent, because they're looking at how much water is actually there compared to how much water it actually could hold. So if it can hold 100 milliliters of water, let's just say that, and it's only holding 10 milliliters of water, well then it's a 10% relative humidity. So the lower the relative humidity is, then the less moisture there is in the air. So once we've got water in our air, it takes more than just the saturation to make it rain. We also have to have our air cooled down to its dew point. So the dew point is where dew forms. Dew is the little bits of water that forms like on plants and things like that. It's condensation. So if you have a cup that you got that's not like one of the insulated cups, but like a regular paper cup or a glass, something like that, and you put ice in it, and especially in the summertime, and you get condensation on the outside of the glass, that's the dew point. That's showing condensation. So the air, warm air, when it touched that cold glass, the warm air got cooled down to its dew point. The water didn't come from inside the glass. The water came from the air outside the glass. So anything that's running down the side of your glass, as long as you didn't spill your glass, all that moisture running down the side of your glass actually came out of the air. When the air touched the glass, it cooled down and it condensed. So the specific humidity is just how much there actually is in a kilogram of air. So what they'll do is they'll actually capture the kilogram of air and then they'll dry it out. And they can do the weight differences. So with some very sensitive instruments. And we're going to look at an instrument that does it in the that we can use just in the air that will tell us what our relative humidity is. So once again, because our warm air can hold more moisture than our cold air, we would expect that in the tropics we would have a higher relative humidity than we would down, and we would have more moisture in the air, or higher specific humidity than we would down at the poles. But the poles can't hold as much moisture, so there's relative humidity might actually be higher down there, just because there's a smaller amount that it can actually be out of. So where you might be able to hold, like I said, 100 milliliters in the air up at the equator, you may only be able to hold 10 milliliters down at the poles. And so if you have 1 milliliter actually in the air, your specific humidity is 1 milliliter per kilogram, then your relative humidity will be higher at the poles, because now it's only 1 out of 10 as opposed to 1 out of 100. So down at the poles it would be 10%, and up at the equator it would only be 1%, even though it's the same amount of moisture. We're just going to do. So one of the measurements that we can do in the field is using what's called a psychrometer. So, and a psychrometer basically has 2 thermometers on it. One, they call this a wet bulb because it has a little piece of cloth on the end of it that gets soaked in water, and it's kind of attached on there. And then this is called the dry bulb because it doesn't have it. And you use the handle here and you spin it around on its handle, and then you take the readings from the dry bulb and the wet bulb. And then there's charts that are based on your elevation that you can put in. You look across and you see what's my dry bulb, what's my wet bulb, and then you follow it down in the chart to see what your relative humidity is. And in one of the labs that we're going to do, you're going to use some readings off of a wet bulb and a dry bulb. So we've got our saturated air, right? We've got all this moisture in our air, which gives us our saturation. But in order for a cloud to form, we still need one more thing. We still need to have a solid surface. We have to have something for the water molecules to attach to in order for condensation to form. So on the glass example that I gave you, your solid surface was the glass itself. So that gave the water molecules something to attach to. But in the sky, we obviously don't have that, and so it's looking for something else. And so it's looking for little bits of like dust or pollution. You can see on here ice and salts, and they are things for the water to attach to, and it's called a condensation nuclei. Nucleus, remember, being the center of the cell. So in this one, the condensation nuclei is the thing that's in the center of the water droplet. So once you have that solid surface and you have air that is saturated, so you've got enough air, you've got enough moisture in your air, now you can have your clouds forming. And then we have to cool that air down to its dew point. So we need a solid surface, we need saturated air that is cooled down to its dew point in order for clouds to form.